Well, hello, good morning, good afternoon, or good evening, depending on where you're located. I think it's good morning for us here in the United States. This session is and really happy that you joined us here today for this. This session is focused on one of the newer IBM offerings focused on data and AI, named the IBM Cloud Pak for Data, and how EDB Postgres and PostgreSQL community integrate into the Cloud Pak for Data platform. The session's going to review, first off, an overview of Cloud Pak for Data. We're going to set the stage there. That's not going to take too long. And then we're going to jump into two more detailed demonstrations. And Peter Coleman and Prasa, who you see as well on the pictures, will be presenting those portions. I'm going to start with the first piece of today. So after the overview, we're going to demonstrate data virtualization. We're actually going to use a number of databases in this presentation. If you don't know what data virtualization is, don't worry, you'll get there along with us today. But we're going to demonstrate virtualization with including EDB Postgres as well as MongoDB NoSQL data in a virtualized environment. And then lastly, we're going to show one of the newest capabilities in the Cloud Pak for Data portfolio, the ability to automatically deploy an EDB Postgres database on Cloud Pak for Data, which is based on Red Hat OpenShift. And Prasa is going to go through that piece of the demonstration as well. Okay, so moving forward here. First off, businesses, want to modernize, right? And, but they want to modernize, at the kind of the place and choosing of their own and in the time frame of their own as well. We know that modernization, centers and, one of the cornerstones of that is access to data, and really access to data, to do something. Which probably is obvious here. So when we look at the Cloud Pak for Data platform, which we're really excited about, if you kind of look at it from a very high level, it's about data access, protecting and governing that data that you make accessible, being able to evaluate that data, and then being able to use some, exciting capabilities to gain intelligence and evaluate that data, ultimately enabling you to take some kind of action. And the idea here with the Cloud Pak for Data platform is we give you a starting point where key capabilities are made accessible that come with the product. You can extend those capabilities and grow those capabilities over time, at a rate that's comfortable to you. Okay, so a little more detail on what is Cloud Pak for Data. If you kind of look over on the left, we'll talk about a ladder to AI. Many organizations are moving towards the need to get greater intelligence out of that data and do it in a automated but powerful fashion. And we look on that as having stepping stones or steps toward that ultimate enablement where you're sitting on top of this ladder to AI. And if we want to put it in swim lanes, we start with collect. This really it gives you the ability to access and manage and organize data, as needed as you move forward. You could certainly see that, many familiar IBM data stores like DB2 and DB2 Warehouse are part of that. But we're also integrating other data stores as well. And we've got key partnerships here. One of our very key strategic partners from, for the last several years has been EDB Postgres and, MongoDB as well. And so those data stores and capabilities that those technologies provide, then that our partnership provides and extends, are all part of that collect rung on the ladder. And then of course is when we look at the second swim lane, where we look at organization, the ability to search the data, the ability to transform it, and maybe protect or hide parts of that data as well, making sure it's accessible and you decide who can access it, and really creating policies, rules, and privacy around that data environment. And then, what I think, maybe the most exciting of all of the rungs here is analysis. And I think many of you have heard of the Cognos brand and the Watson brand of offerings. And there's a core set of capabilities, and we'll talk about that, built into the base Cloud Pak for Data platform for analysis, but also for moving that data forward into a much more intelligent gathering environment with a set of Watson branded offerings as well. And when we look at sort of managing this environment, we're basing it on Red Hat OpenShift capabilities to log and meter and monitor, to pick your storage environment of choice, manage security, access and access as well. All part of this all part of this standard Cloud Pak for Data environment. Okay. The environment itself, I'm not going to spend a lot of time on this, but it sits on Red Hat OpenShift. OpenShift's a tightly integrated stack. You can kind of think of it as infrastructure as a service with an operating system and with Kubernetes kind of working in tandem. And access to that environment and management of the environment is provided through UIs, through updates, through a set of core, I'll say, standards that are adhered to, and that you can trust are adhered to, today and moving forward as well. And again, the same environment can run in private cloud environments, public cloud environments, or both. What we talk about as hybrid environments. I want to just touch on and stress in a little more detail some of the base services, and you're going to hear and see some of these in action as we get into the demos. But when we look at kind of where your data can flow, it can flow through data virtualization, providing easy access, kind of beginning with a connection environment. The Watson Knowledge Catalog service kind of helps you organize data through classification and governance, and really becomes a cornerstone of defining that data, data and information architectural environment. Really allowing you to understand what you have today and scale up moving forward. And then some of the other key services that participate here, things like Cognos Dashboards, giving you really exciting visualization of that data, Streams, which enables you to drive real-time updates and decisions of data, on the fly, Cognos and the SPSS modeler to create data models and, extend visualization even further. And then, Watson Studio really providing a kind of an open source based environment for more detailed data analysis as well. And Watson machine learning to allow you to build on top of that. And so, kind of as we move forward here, I'm going to turn it over now and get into the first demo. We're gonna organize the demos, starting with the problem and then going into the solution. So I'm going to turn it over to Peter Coleman now. Peter?
Hey, thanks, Michael. So one of the things that Michael mentioned that is a key feature of Cloud Pak for Data in the collection of data is data virtualization. And if we look at a typical problem space, and the scenario that we have here is a company called Acme Brokers, think of this as an international brokerage that's acquired a lot of other companies under its umbrella. It works with not just multiple brokerages that it's acquired, but also different stock exchanges, multiple customers. And it's actually collected data, customer data, their account data, trading and stock history data. And they have a data science team that really wants to be able to pull insight from this data from across our enterprise. And you think, okay, this should be relatively easy thing to do. Mike, if you want to continue, but next slide, please. But this is actually a lot harder than it looks for this particular customer and for a lot of our customers. The data is actually on multiple heterogeneous data servers. Some of those data servers are running on premises. Some of them are on multiple cloud providers. Data is maintained by different teams and different organizations. And data governance is mandatory for this ability to protect customer data, trading data for specific customers, who gets to see what is critical for the solution as well. And what they're really struggling with is that traditionally they've used a warehouse, very typical of our customers for the last 10 to 20 years, where they would replicate the data from all these multiple sources. They would have export, transform, and load jobs would run on a continuous basis to pull data together. They'd have staging data in their warehouses, and they would pull all this together into a central database. And remember, the big problems they've got with this is that replicated is always out of date. It's also expensive and time consuming to pull that because you're pulling data whether you actually need it or not. And again, that data is always out of date, and it's always old data. So, next slide, please, Mike. What you really want to do is to make this big integrated data state that you have with data that may be on multiple servers, some on the cloud, some on-prem. What you really are trying to do is simulate or that experience of the warehouse, but without having to move all that data. And next slide, Mike. What we're really trying to do is to make that mess look like something as simple as a single database with a single connection where you can manage all of your data, but again, without moving all of that data and the expense of doing all that ETL work. Next. So what data virtualization does is it allows you to access that data, work with it like it's a single database, connect all those heterogeneous data sources, and actually use advanced SQL to pull that data together, to join it, to create unions of the data, views of the data, just like you would a powerful database. But it makes all that remote data look like it exists within your database, just like it was really within a local warehouse. It allows you then within Cloud Pak for Data, with the integration with things like Watson Knowledge Catalog, to do deep data governance, to be able to classify data, to be able to decide if you want to redact data for certain users, to substitute or cloud the data so that you can protect user data, but still make it useful for a data scientist. And of course, because this data is remote, you're also going to be sensitive to performance. Having things in a local database is always going to be the best performance option for 10 terabytes of data. But if you talk to data scientists, they'll say the vast majority of the data that they're using is not necessarily the terabyte level data. They may have a couple of tables that are in that level. They may have other data that's in the megs or tens or hundreds of gigabytes of data that if you could just pull the data in efficiently and just cache what you need, you're going to get all the benefits of having a warehouse without the excessive cost of that. And that's what Cloudpak for Data and Data Virtualization does, is allows you to cache that data. And of course, you can connect with existing tools just like you're connecting to a single database. And that's really the experience that we're trying to provide here, is to make that data estate look, act, and feel like a single database. Mike, I'm just going to take over the screen now and just start sharing my screen so that I can give people a feel for like when they're using Cloudpak for Data. And just let me know if you can see. I'm going to go to a full screen size here. And within for Data, the demo environment that I'm actually running on a real Cloudpak for Data system. All of the data sources that I have here are live. You can see I've got connectivity to about 13 different data sources. There's also direct file connections here. I can virtualize CSV files on disk as well. To give you an idea of what we're looking at in this particular system, we've got a little dashboard that shows you the different data services we've connected to here. I've got DB2 on-prem running AWS. We have Postgres running on Azure. I've got Enterprise DB running on-prem as well. We've got vSAM data on MDS and a T performance server, MySQL. All these services are up and running, and we're polling them, knowing that we've got continuous connection. And what we've actually done with this, and remember, this is a live demo that we're showing you, is we've built an application that's pulling data from across all those different multiple data sources to provide connectivity into this application. The application is actually running in Python in a Jupyter Notebook, and the application is built to connect to a single database connection, and it's connecting to all that data from all those different data sources as if they were just individual tables. So let me show you what it looks like within the Cloudpak for Data interface. If we take a look in here, the data source that we have, we can look at these either as a table or constellation view, and I can add new data sources if I want to in here. I can select the data type that I want to connect to. I can even add my own custom drivers if there's something I want to connect into here that's not part of the default set, or there's a driver that we haven't necessarily provided for you. Now, once those connections are established, I can then go and virtualize data, which means that I can go in, like say virtualize, I'm going to go and get a view across my whole data enterprise, all the different data sources that we're showing. We're scanning across all the different tables in the catalog that we have of all those different data sources. And you can see I can go and pick through this. Let's say I want to take a look at something called payment. It's going to go and find all of the tables across that whole enterprise. In this case, there are two in one of our Mongo databases that has the name payment in them. I can go and preview that data, or I can go and select these. I can add them to a cart, just like a shopping cart, and I can virtualize that data and make it part of that set of tables that reside outside of Cloudpak for Data, or they may even be in a data source that we provisioned inside Cloudpak for Data, but we're making that look like a local table. But once that data has been virtualized, once we've said we want to make that connection, you end up with a set of tables. As you can see the ones here, I've got about 6 pages of these tables that we virtualized. We've got some from Snowflake, some from Netezza, data sources that we've got in here, and all of these are directly available within the system for us to access. So for example, if I want to go and preview one of these data sources, I can actually see the data. I can take a look at the table structure, the metadata. Everything I need is within there to get that data. Now, that's terrific, but I want to be able to access it. Remember, you can connect to this like it's a database. You can see I've got my connection information in here. I can download SSL certificates if I want to connect to that data directly. And just like I was integrating into that stock application, I can actually go and look at some of my own queries. So what we're looking at now is a Jupyter Notebook, which is going to give us a demonstration of connecting to the data virtualization engine, just like it's a normal database engine. In this case, the SQL that we can run is identical to what you can run on a standard DB2 database. So the first SQL I'm going to run, this is actually going out to a vSAM system, and this may look like a simple table within the data virtualization engine, but it's actually pulling that data from a vSAM file from a System Z system that's running out in Boston, probably about 3,000 miles away from where this data virtualization cluster is actually running. Now, there are a lot of examples in here. I'm going to jump down to one of the more complicated ones we have. This is actually pulling together data from multiple different data sources, including VMware that's included with within the cluster. And I'm going to start that running. This is actually pulling data from the top customers in Ohio that bought the most stock during the highest trading day of the year. So this is figuring out who those customers are, what the highest trading day of the year was, and figures out what those top customers were and puts them in order. Now, what you're doing is not just pulling all those tables that look like local tables and pulling that into a result set. You can simplify that even further. In this case, I've actually created a view for that query. And if I run that, I'm going to get the same result set, the same query, but you can see this trading Ohio, while it's running a complicated SQL, it's pulling data from multiple sources, getting the same result set from something that looks like a simple table. The other thing you can do is you can actually mask data from this data source that we're running. You can see that the card number information has been redacted. And I'll show you in a second how that's done. It's actually done with a combination of Watson Knowledge Catalog that allows you to classify data, lets you protect data, and even push down deep data protection that through the data virtualization engine lets you mask and redact data so that even if you're an application developer, you can't access data that you're not supposed to, but you may still be able to run queries in that protected mode. So if you want to see what that looks like from a data protection perspective, I've actually a separate web browser here. I'm logged in as a data steward. It's a different role within the Cloud Pak for Data family. And I've got my different data sources that have been cataloged in here. The data steward has ownership and can manage those different data sources. And I'm just going to pick one here that had that sensitive data in it. And you can see that's been classified as credit card number information, and it's been redacted by the data steward. Now, the way this is controlled is that you can actually create rules, and the data steward within the Watson Knowledge Catalog, in working with data virtualization data, can actually set up rules. In this case, it says if we find data that's been classified as credit card number data, then we're going to redact any of the columns containing that credit card number data. And you can change and modify these rules across really your whole data estate. The last thing I mentioned, remember we showed that we could virtualize data, we could connect to it with a normal application. From an application perspective, you can actually also connect using RESTful services. Because data virtualization really is built on the DB2 standard engine, you can reuse a lot of DB2 style services. In this case, we're using the DB2 RESTful services and endpoint service. So I'm connecting into that service. I'm going to go and get a token to talk to that service. And I'm going to get a token and a result set for that. And I'm going to set up a header to be able to go and connect into that. Now I can run statements, but I've actually created a unique RESTful service for this ahead of time. And it's going and connecting to the data for a particular service to get credit card information or payment information. And again, if I run this service, this is passing through a RESTful service customer ID. And what I'm getting back is through that service, I'm getting a JSON result set that's giving me my credit card type based on my customer ID but again, I'm protecting that data like we just saw for the customer number. Now, obviously, performance is an issue in anything that we do. And what we have within data virtualization is the ability to manage caches so that we can actually cache a result set. We don't have to keep a copy of the whole table the way you would in a warehouse. We can actually cache, just cache the result sets from particular queries. We can analyze those queries, and we can save the result sets to dramatically improve the performance for particular queries in the system. So you're not paying the extensive cost of running a full warehouse or doing ETL. You just have to pick the queries that you want to accelerate, and you can keep that data into a local cache with data virtualization as well. So I'm going to just hand this back to Michael now so we can go through the next scenario. Thanks a lot.
Okay, and so now what we're going to do here is we're going to walk into scenario 2. Think about developers and data miners needing to do very quick, secure deployments, and we're going to show that happening in the Cloudback Data Red Hat OpenShift-based environment. So with that, I'm going to stop sharing and Prasa, I'm going to send it over to you.
So we're going to take a quick look at the experience of deploying different databases on Cloudback for Data. Database deployments on Cloudback for Data are very straightforward. So what you see here is the general Cloudback for Data user interface. This is kind of your starting point to access many of the different functions on CP4D, but right now we're just going to look at the databases component. So if I click here and we take a look at our existing instances, what you're going to see is, at the moment, I have a few instances already deployed. So I have an Enterprise DB Enterprise deployed there and also a MongoDB. So you have access to several types of databases here, and I'm just going to go ahead and create a new one in addition to what we have here. So straight off the bat, here you'll get a list of installed databases. We have 3 options here, but for example, if we had a DB2 available or another product, that would also be available here. I'm going to select the enterprise version of Enterprise DB as what I'd like to deploy. And so at this point, you'll start to get options for your deployment. And there are just a few options that really need to be filled out in order to get this going. First would be the number of nodes, for example, that you'd like in your Postgres deployment. And as part of this interface, it's scanning your OpenShift cluster. And if you make a selection that's not going to be attainable, let's say, with your cluster, then it will warn you here. So in this deployment, I have 3 nodes available. So I'm going to select a 3-node cluster. Similar applies to your selections on memory and CPU. If I go over the limit of what I have available, again, I'll get warned here. And then the minimum and maximum values, again, will be reflected on the screen. So in this case, I'm going to select 2 cores for my instances and 2 gigs of memory. So that means every pod that's going to get scheduled as part of this deployment is going to adhere to these as its limit, as its upper limit. So if we continue here, you'll see an option that applies specifically for the Enterprise Edition, which is Oracle compatibility in Enterprise DB. And so I'll go ahead and select that. And then finally, the last option that you have to worry about here is the storage. So how do I want my storage on my cluster to be provisioned? So Cloudback for Data, most services, like most services, Enterprise DB will use a storage class. So as long as you have a storage class selected here, PVCs will get created accordingly, and then in the background, the volumes will get created and attached to the Enterprise DB pods. Now in CP4D, the advised storage platforms would be OpenShift Container Storage or Portworx at this time. And that's really all there is to starting an initial deployment. So if I go ahead and click Create here, you'll see that essentially we'll go into a phase of deployment. It'll walk through the initial steps, and you'll end up with a running system similar as to my other products that I have deployed here. So once I have that ready instance, if I take the previous one as an example, I can go into the details page and I can see various information that I'll need to work with it. So for example, if I needed to do any maintenance on the nodes themselves, I can get that information from this page. The initial credentials that you need to connect will be available here. And then probably the most important is the connection details. So these connection URLs, you can take them, you can copy them and use them elsewhere to create connections between services in Cloud Pak for Data, such as, for example, the virtualization integration that was shown earlier. And that is essentially the deployment experience on Cloud Pak for Data. So with these simple steps, if I were to go over now to the OpenShift cluster, you can see that I have various enterprise DB pods having been spun up and running and ready for transactions. And that brings us to the end of my my presentation here. Thank you.
You saw some hopefully a great portion of Cloud Pak for Data presented in a easily consumable way. Over on the right here are some of the values that hopefully you saw as well. You know, values related to you know, general value, you know, containerized deployment, cloud native databases, you know, accelerated time to value, but also specific value like virtualization, security and management, data science, and enhanced productivity across various roles in your data consumer organization. There are some links here that you could use to get more information about Cloud Pak for Data and the open source database community that participates in Cloud Pak for Data. And there's also a kind of a try it out link as well for those of you that want to get hands on. You certainly, we would invite you to do that, and you know, would you know, certainly would be in touch as you do that as well. And you know, if you go on the link, you'll see how to make that happen. And I think with that, we're going to open it up for questions and answers. And I want to be sure to thank everyone as well. But we're going to be on here for about 10 minutes or so answering Q&A, and then also, you know, perhaps in other parts of the event as well. So thank you very much.